Like I said, we're Arrowhead Forensics. My name is Parker Sned. This is Quinn Carr. We're a team that travels the country frequently. This spring and fall are very busy for us, attending state IAIs, going up and doing some training workshops. We just got back from Iowa IAI, Nebraska IAI. We're up in Chicago, over in St. Louis doing an alternate light source class. Probably forgetting some of them, but that's just in the past month, really. And then obviously we came here, and we really enjoy this. We like hanging out with you guys. We like getting to know the law enforcement personnel. We love our job. We get to go to crime scenes and death scenes and figure out, get in your guys' shoes. We really pride ourselves at Arrowhead in being innovators. And we can't develop new products. We can't figure out what your needs are unless we're with you. And so we like to go out with you to scenes and do ride-alongs like we did at the Chicago Police Department and figure out, what are you guys thinking? What do you need? And we have the resources, the time, and that's kind of what we do is we're innovative and we develop products. And so we love traveling and hanging out with you guys and getting to know kind of what you do and getting in the trenches with you. We were just at Chicago PD, as I mentioned, and we would have never known this, but we were up there touring their crime lab, and they had some questions about products, and we have a contract with them, and they just moved into, just to give you an idea, perspective, something that's unique about our company and getting able to be in front of you guys and talk about some things is we do see a lot of different crime labs and talk to a lot of different personnel such as yourselves. But the Chicago Police Department, they've got a brand new facility, well, it's brand new to them. They inherited a Sears warehouse building that's 50,000 square feet, probably 50,000, at least 50,000 square feet. I mean, it's humongous. And half the building's the crime lab, half of it's, I think it's for working out and stuff. But they just use half of it to process evidence. But they go through a lot. They process 500 homicides a year, which is probably a lot compared to kind of what you guys go through. Certainly, where we're from, in Lex, Kansas, and Johnson County, there's 2 to 3 homicides a year. A lot of rapes, but not as many homicides. And so, as we were talking to them, they kind of told us, this is what we need, this is what we like, what you guys offer. Here's how you can improve. Here's how you can help us. And so that's what we like to do. So that's what Quinn and I do. We travel the country and we do that. It's a lot of fun. Arrowhead Forensics was incorporated in 1993. We've been in business selling forensic products for 10 years, and we just really like it. So that's just a little bit about our company, end-to-end forensic products from the crime scene back to the lab and anything in between. So just a brief intro of kind of what we do. Okay, at this point, Quinn, if you want to hand out some catalogs, and the reason we're doing this is so you have a reference point as we go through the products. It's a lot easier to do that than print out 500 brochures, one for each product. And I think Quinn's earmarked a couple of those pages, right, Quinn?
Yep, RUVIS is.
Okay, very good.
And you don't have to take one of these if you don't want, if you already have one back where you're from, so don't feel like you need to take it. But
yeah, definitely not obligated, but good reference materials to kind of go through these. All right, as Quinn's doing that, I'll kind of get started here on our PowerPoint.
I jump in real quick.
Yeah.
Yesterday, I guess you were there, we were talking about a product called Undo. It's sort of hard to get through the catalog.
Yeah.
If you're interested.
Yeah, thanks for bringing that up. We just signed an exclusive deal with the manufacturer of Undo. We're the only forensic company that can deal Undo, so thanks for that. I appreciate it.
Yeah.
Okay, let's get started. As Quinn's handing out these catalogs. As we begin here, I do want to lay the foundation of what a RUVIS system is. I think sometimes there can be some confusion when you hear the term RUVIS. Am I right? Raise your hand. A little bit of, okay, what does it do? Is it a camera? Is it a light source? What do I process with it? And so here's 3 examples of different RUVIS systems that we offer. We're going to mainly focus today on our total workstation, which is this equipment right here, everything you see here. But we also offer, and I'll go through the specs here in a moment, a mobile version that you can take to the crime scene, and a UV viewer that you can record video in the ultraviolet range. So my question to you guys, I kind of want to get an understanding of your background of using RUVIS. If you have any experience with it, typically at the IAIs there's a range of experience and what you guys have gone through. So I want you to answer this. What comes to mind for you individually when you hear the term RUVIS? Anybody?
What was the question?
Say it.
Like rover?
Rover?
Something that's portable?
Portable, okay. Portable, very good. What else? I can tell you what I've heard from you as we've talked this week and from other departments. But I want to hear it from you if you could.
Non-destructive light examination.
Non-destructive, very good.
Really?
What else?
I was hoping you guys would share maybe.
She didn't like to share.
A good tool, okay. Who has experience with using a RUVIS? Raise your hand. Just a couple? 3? That's good. Very good. So these are the 3 systems that we offer. Let's kind of get into the details of this. Okay. This is our total workstation. As we go through the specs here, I will point out exactly what you're seeing over here. And I know it's kind of hard to see from the back, which is why I wanted to include an image. But we chose the Apple iMac as the display unit because that is the largest resolution all-in-one screen you can buy today on the market. There are several other companies that make all-in-ones or different screens, but the Apple has the biggest resolution. So when you're capturing prints, capturing images of prints or any evidence, as you're processing, the clarity that you're seeing when you're processing is fantastic. Another reason we chose it, the technology, the ports actually, this FireWire 800 port, this Thunderbolt port back here, allows the data to transfer from the camera to the workstation quicker and more efficiently, and it's a one-to-one transfer, so you don't lose any data as you're capturing images. Obviously, the 16-megapixel RUVIS camera is right here. So there's the camera. You've got all your different light sources. The copy stand. There is a foot pedal, allows hands-free image capturing, and all the different filters that you need. And I'll kind of get into that here in a minute. But just a few highlights. The 16-megapixel camera, hand-free foot pedal, copy stand, filter set, and I want to emphasize this the most as we go through this is a full spectrum imaging system. From what I've heard as I've talked to you guys and other departments is they've used RUVIS mainly in the reflective UV imaging system. But this total workstation will actually allow you to capture images from UV all the way through infrared. Okay, next slide here. Okay, I'm going to make my way over here. This here is our mobile version. This was actually designed for the Army, the late print division of the Army. So over here. So it comes in this Pelican case, and it's designed specifically to be transported in an airplane. So the Army came to us, the manufacturer of the RUVIS system, and said we need something where we're in Afghanistan, Iraq, wherever they might be deployed, that we can hop on a plane real quick and throw this thing in an airplane and be dropped in the middle of the desert. But at some point, we can still process evidence. So we said, okay. So this is the mobile version of the RUVIS system. A couple key differences to the total workstation is that the workstation is a 27-inch iMac, which is the largest all-in-one, as I mentioned earlier, you can purchase. The mobile version is actually a MacBook Air. It's a 15-inch screen. We've actually custom made a few of these for different departments, for the FBI. Sometimes they want, well, let's take a 27-inch, and if it's a major scene, let's deploy it. But also, we want someone at the command center to be able to manipulate or enhance images or capture with the mobile version. So there's a couple that we've custom made like that where you can get both monitors, but just to give you an idea of what we offer, that would be the total workstation, and this is the mobile one. Again, still full spectrum, so it has all the different light sources with it, starting in the UV all the way through IR. Any questions as I'm going here? Please feel free to raise your hand and ask. I know we've only got about an hour here. I'm trying to kind of
What kind of mobile power sources that have?
Mobile power source, good question. The MacBook Air is just general, runs off, plugged into the wall. And the core of the camera actually doesn't run off power. It just is a USB port from the camera directly into the MacBook Air. So that's where it generates its power. Good question. Okay. The third version, need to go through here, is our viewer recorder. This is typical probably to what you guys have seen. I'll pick this up here and show you. See one like this maybe?
Yeah.
A viewer. So the RUVIS viewer is great for crime scenes. If you're at a scene and you need to view in the ultraviolet range, then this coupled with UV light, shortwave typically, which is 254 nanometers, you can see the prints at a crime scene. So a general scan will allow you to see unseen evidence with your naked eye, or hidden prints maybe on a wall, or different surfaces with a general scan. The thing that sets this particular system apart is you can actually record video in the UV range. So it's mounted with a digital camera that has video optimization. So if you're at a scene, and I've talked to, for instance, Johnson County Crime Lab, who is the bigger crime lab in our area, they came to me and to several of us and said, hey, we want to be able to record video. And the reason that being is if there's a blood trail or a trail of specific evidence that you want to record in video, you can play back or store the data at your lab, or if you're in court presenting, you can play that back with video rather than just still imagery. So that's what sets this particular system apart. Okay, let's kind of get into the specifics of the total workstation. So a quick definition is a camera system that allows visualization of evidence that would otherwise be invisible to the naked eye. So that includes, we'll kind of jump down here, latent prints, which can be invisible, not processed at all, or lightly fumed, or processed completely. If you fume and then apply powder or a dye stain, you can take an image of that particular latent print. Moving into biologicals, urine, semen, saliva, bones, trace evidence, question documents, cartridge cases, and that's just a few of obviously the more typical evidence that you collect at a scene. But so it'll allow you to view all that evidence from 254 all the way through IR. As I go through these specifics here, we're going to get into, I'll display it on the screen so you kind of see, what light source do I use, what filter, and what evidence can I see specifically. So as I mentioned before, it's 254 through IR. The name of this system, and this is a brand new system that we're going to look at today. It's about, Quinn, 6 months old, is that about right?
Yeah.
We could have named it something funky like reflective UV, blue, infrared, all the way up to, system. But we couldn't really think of a great acronym. And we know that you guys are familiar with RUVIS, which is a reflective ultraviolet imaging system. But that really hinders this total workstation because it's not just UV, it goes all the way up through IR. So it should be something a lot longer, but we chose RUVIS because we know that you guys are, and the market itself is familiar with that term. Okay, kind of some technical data of this system. Okay, who has an iPhone? Okay, iPhone. Does anybody know how they market the camera system, what the megapixel is? Off the top of your head? They're pretty proud of this, by the way. How many megapixels in an iPhone? Anybody know?
10?
A little bit lower. 8 megapixels. So if I have an 8 megapixel camera and I go to a crime scene, or I'm processing prints, processing any evidence, and want to take a picture, is the resolution going to be great? Anybody know what the pixels per inch would be if I'm taking a picture with an 8 megapixel iPhone?
326.
356, who said that?
No, 326.
326?
I was reading the thing.
Very good. Steve, pay attention, right? That's right, 326 pixels per inch. The APHIS requirement for the FBI is submit an image. Have you guys learned this week? I think someone told me. It's right here, but didn't you learn this in one of your classes? 1,000 pixels per inch, or you know this from experience? So that's what sets this particular system apart, is that you can capture an image at 1,000 pixels per inch. So let's go through this chart here. Starting with the camera distance at 4.5 inches. Your viewable surface is 2.5 by 1 3/4 inches, and the pixels will stay the same throughout. But if you're 4.5 inches from your surface, which about like this, then your pixels per inch of your image that you're capturing is going to be 2,000 ppi, okay, which is a very large image. All the way up to 9 inches, and rarely, and I'll show you this later, but rarely are you going to be getting any higher than that. Your image is going to be 1,000 pixels per inch, which allows you to capture almost a 5 by 4 size image, which, based on the FBI requirements, we talked to them, we traveled to Quantico, and we partnered with the company that manufactures these RUVIS systems. And they wanted and I'm sure the shortcomings of using a RUVIS sometimes, you may have experience with this, where you can capture a late print, but anything really bigger than that, you lose a lot of clarity. So with our system, you can capture up to almost 4 by 4, and which allows you to capture a handprint or a palm print with 1,000 pixels per inch clarity. So we designed it based on their specifications and requirements to allow you to capture an image that large. And then if you get over to 18 inches, up to 18 inches, then the resolution goes down a little bit. A good example of this would be a footwear impression. So if you have lifted dust impression with a gel lift or a stat lift, like your static dust lifter, and you want to take an image of some of that footwear, then you're going to still have a 500 pixels per inch image. And correct me if I'm wrong, from what I understand, is submitting to their database, there really is no requirement as far as pixels per inch when collecting footwear. Has anybody heard that before? I know I've talked to them and they said that, but very different.
There's no.
Yeah. Very different from prints or submitting to APHIS, which would be 1,000 pixels per inch. So it still allows you to capture foot impression. Okay, I've mentioned most of this, but what's the difference between this system right here? It's a 16 megapixel camera versus a 1 megapixel, which up till we launched this particular product was the industry standard. Again, 1,000 pixels per inch image capturing. It's full spectrum from UV all the way through IR. The camera itself is also the RUVIS. So it's a reflective UV imaging system, but it's also a camera, so it's an all-in-one system. So instead of what I've seen in the field typically is you have your RUVIS and you mount your camera on top of it and take your picture. This is actually a camera and RUVIS in one. So it allows hands-free photography. You don't have to be jacking with a couple different things at the same time. Again, 4x4 image, and this was specifically manufactured to the FBI standards. This chart over here is actually in our catalog, right, Quinn?
Yep.
And it shows you what evidence, what filter, and what light source that you can see particular different types of evidence. I think it's toward the back, right here.
Yeah, I believe so.
Okay. Okay, let's look at some exemplars, and then we'll do some live viewing here in just a moment. Okay, this is number one. This was actually processed with that PDMAC paper that we referenced at the beginning here. Let me move over here so I can give you a visual of kind of what we did. Okay, so thermal paper. We took this receipt, had some prints on it. Couldn't really see them in just typical daylight or natural light in the room. That's a photo with just a standard camera up there. I think it was a Nikon, if I'm right. Okay. So we took that same thermal sheet, put it underneath the RUVIS, and it was processed, like I said earlier, the PDMAC is mostly an anhydrous. So it's an anhydrous process print. Put it under the RUVIS with an orange filter, orange camera filter, just screws on right here, and a blue alternate light source. Took an image, and that's the print that we got. So visual, just in standard lighting, and then with the RUVIS. And this image right here is probably about 1,500 pixels per inch or so. So plenty for the APHIS requirement. Okay, so late prints processed with anhydrous, or really any chemical process development that you currently use. Number 2, gunshot residue. We were at the Johnson County Crime Lab again, and they had a black shirt that had been shot, and someone was wearing it, obviously, and very difficult to photograph any GSR with just a standard camera, or even if you're using a light source with a different lens, still very difficult. So this was a standard camera shot right here. Put it under the RUVIS and shined an infrared light on it, put an infrared filter on the camera, and you can see the obvious contrast of the GSR and the t-shirt. Okay, number 3, reflective surfaces. This is a big problem when you have a print on a reflective surface. It's very difficult to take a picture because what happens? Anybody know? Someone said flash. I heard it. Or just the standard lighting will reflect, right? So whatever's above the mirror, if you're taking an image of that print, you're going to see what's above the mirror. Or if the camera flashes on, it's going to bounce up at you, and you're going to get almost no clarity. One distinct positive and feature of the RUVIS system is that it drops the background out of a reflective surface. So that, again, first picture up there is an image which is a standard camera. Very few, you can kind of tell there's some prints on there, but not a lot of detail. Put it under the RUVIS, and this is at 254 nanometers, which is shortwave UV. Shortwave UV with the RUVIS will completely take the background down. I'll show you that here in a little bit. Prints illuminate really nice. That's probably 1,500 to 2,000 pixels per inch. Okay, same kind of deal here with a credit card. Is if there's prints on a credit card, there's a lot of data in the background with the airplane and whatever's on credit cards these days, right? Put it under the RUVIS with 254 shortwave light, and that's this right here, by the way. This is a shortwave lamp. It's also long wave, which is 365. You can toggle back and forth depending on the color of the evidence and what you're processing. Snap the photo there. Clear difference, obviously. The background's completely removed, and you can see the prints. These were lightly fumed, probably for 3 to 5 minutes at our facility with the microburst technology fuming chamber, which heats up to 375 in 3 to 5 minutes. Different ways you can fume, but that's kind of the way we do it at the same time in our office. 1,000 pixels per inch there, probably more. Okay, let's move into infrared.
Parker,
Yes.
tell them a little bit about how long it took you to capture those images.
Oh, thank you, Quinn. I think about 2 minutes.
Yep.
Yeah. So once you have your evidence and you're thinking, okay, there might be some prints on here, the process, and I'll show you this later, the process of putting the evidence underneath your camera and hitting it with an alternate light source and making sure you have the correct filter and then capturing the image is very quick. It's really just a matter of focusing, making sure your aperture, your f-stop is correct, and then making sure also your exposure level is accurate. And that's about it. Capture the image and you're done. So about 2 to 3 minutes there. Thank you for pointing that out. Okay, infrared. Question documents, people. Anyone process question documents? Very good. We run into these, you guys all over the place, for sure. We were up at the Iowa Crime Lab, State Crime Lab a few weeks ago, and they have a great facility, and they have a guy that's, his name's Gary Lick, that's a very good question documents guy. Anyways, I grabbed a drill there. But, so this is a check that, to the naked eye, or just photographing with just a standard camera, really, you can't tell that this check has been altered. Put it under the RUVIS, hit it with infrared light, infrared filter, and originally, my face is going to be hit here, but made out to the IRS for $5. Someone had written over it with a different color ink, and you can see the contrast by putting it under the infrared light. So clearly this check was altered. This is not actual evidence. This is an exemplar that we made at the office, but you can clearly see that at some point when there's an altered ink, different colored ink, if you put it under the infrared light, that the contrast is very visible. And again, in just visualizing with your naked eye, there's no way you can tell that check has been altered. Again, a couple minutes there to process that. Okay, 2 more here. Moving into the 450, 455 nanometer, which is a blue. Be a light like this for processing biologicals. That is a white piece, I think it's a white sheet. Yep, white sheet up there. Again, standard photography. Really nothing there. But hit it with a blue light and an orange filter under the RUVIS. It's a semen, urine, and saliva stain. A couple minutes there, 1,000 pixels per inch. So the reason I threw these couple in is I want you guys to understand that this is a full spectrum imaging system. Yes?
Can we use the blue lights outdoors?
Sure. Yeah, absolutely. Yep. Good question. You can use the blue lights outdoors, yes. The same blue lights that come with the lab version also are equipped in the mobile version. Yeah.
Can you stack images?
Can you stack images?
Yeah, in case if you ever have a situation where the luminescence is, fluorescence is just a little bit, if you can restack the images on top of each other, you can show it. The more you stack, the greater contrast you can show.
Good question. I've never had that question.
Sounds like that's a prep process too, so after you capture. So
Yeah.
within the RUVIS system now, after you capture,
But you can maybe, okay.
yeah, that's your prerogative.
Yeah, so after you capture the image, it's saved as a TIFF file or a RAW file. So however you want to enhance the image after that, there's software built in here called Latent Master. But if you're familiar with Photoshop and overlaying images, then yeah, you can do it after you capture the image. Okay, sure. Yeah, good question. Okay, one more here, and then we'll get into some live viewing. Okay, this is lightly fumed prints on a magazine. I think that's a gorilla hair or something, isn't it?
Yep.
Something like that. So I just wanted to show that with multicolored, lightly fumed, even if it's not fumed, you can sometimes see prints that have not been processed at all. So again, a couple minutes here, 1,000 pixels per inch, about a 5 by 3.5 to 4 inch image. Okay, so the first thing we're going to look at is it's a CD case. And the reason I chose this is because one side of it is reflective and the other side of it is black, and so it'll absorb light. So very difficult to capture an image on either one of these two surfaces. So this is a shortwave 254 nanometer. So these are 2 prints that were lightly fumed on this clear surface. The 254 nanometer, I'm going to blow this up just a little bit so you guys can see. see the detail in that print pretty easily. Yeah, okay. Okay, again, trying to photograph on a clear reflective surface is very difficult. If you were to utilize just a standard camera and try to take a picture, then the background would reflect. And it would be very, very difficult to see these latents. But because we're hitting it with a 254 nanometer shortwave UV light and the RUVIS technology, the imaging sensor inside of the camera allows these prints to be clearly seen. So at this point, I would save my image, and it would just go based on the file trail that you set up at the beginning. It could be on your desktop, it could be on a server within your building, it could be directly in a folder that you've created, but it'll save it as a TIFF or a RAW file, and then you can enhance it or manipulate it however you want later on. So shortwave UV, and there's a 254 nanometer UV filter on the end of this camera. Take a picture and you're done. We move over to black ones over here. As I'm going through this, please, if you have any questions, feel free to ask.
And this is software that comes with the RUVIS system that Parker's taking the pictures with right now.
Say it one more time, Quinn. Maybe I can say it
This
again.
is the software that comes with the
Yes.
RUVIS system.
Absolutely.
So
This
it's
is
not-
called digital RUVIS. This is an image capturing software. There's another piece to this system, this entire system called Latent Master, which is an image enhancement software. I'm not even going to get into that today because it's really just its own training on its own. But if you're familiar with Photoshop and you utilize Photoshop, you can easily download or upload it onto this system. Okay, so these are 4 lightly fumed prints on a black surface. Shortwave UV light with the UV filter. My f-stop is 4.8. My exposure time is 2 seconds. So over here you can manipulate your exposure. I'll just show you kind of what it does. At this point, the 2-second exposure time is going to be appropriate. But if I take it down to 1.2 seconds, or even less than a second, then it darkens the image. I'll boost it up to 2 seconds. Then the prints are much more visible, and you can see the clarity and detail there. This is my gain over here in this tool. If at the initial onset of trying to view your evidence, if you crank the gain up, it'll make it a little bit fuzzy, but the benefit to it is that it will allow more light into the camera, and after you visualize your evidence, you can take the gain back down and refocus it. Gamma is very similar to exposure in that it will darken or lighten your image. I'll show you an example here. Take it up and lightens the image, bring it back down. Darkens, excuse me, bring it back down and lightens the image.
Is that like brightness, contrast? kind
Yes,
of
it
thing?
is.
All right. We don't know that gain gamma business.
So the user interface on this was designed that it's very simple to use. We didn't want to throw a bunch of controls on it. If you're familiar with Photoshop, I'm not, but I've tried to kind of play with it a little bit. It takes some training and some time to learn. With this, we wanted it to be quick and easy and efficient, where you dive in. It doesn't take a whole lot of training. A couple of days, you can start using it and capturing evidence. Okay, let's move on to we like to do some on-the-spot fuming. So we were staying at the Fairfield Inn, and we can send our apologies to them. We took the room key and fumed it this morning. And I just wanted to show you the detail, kind of what you can see. And you can see the delay time in this. The reason, you can see my finger come up and then come back down. The exposure time is 2 seconds. So as I'm moving my finger back and forth, it's letting in light every 2 seconds. So it kind of, it's delayed and showing the real-time image. If you come down below a second, then it won't be so delayed. That's just so the light, more light can come into the camera, you can visualize your prints. This is a good example of the background being completely removed. This is just a standard room key. It says Fairfield in, it has all this colorization and things on it. But when you hit it with the shortwave light and the shortwave UV filter, it takes the background completely out. This was lightly fumed. I think Quinn, we fumed it for about 5-10 minutes or so.
Yeah.
Yeah. Okay. I can't remember who it was. Someone came by the booth and was asking me about curved surfaces. I'm going to show you a paint can that's also reflective and curved. This would be a tough image to, a tough piece of evidence to process and get a good image. Back down a little bit. So what I'm doing here is, as you can see, right when I put it under the camera, it's a little bit out of focus. So I'm just going to raise it a little bit. I really have two options. I can raise the camera up, or I can change the focus right here. So as I toggle the focus, it's just like your standard lens that you would work with typically. You can see the prints start coming into view. And I might mention one thing too, is when you're processing with RUVIS, not really our system, but any RUVIS system, the angle of the lighting, you can see I'm holding it with one hand here, is very important. So I'm at about a 45-degree angle, and if I change it and come down, it's almost parallel to the ground, or to the surface, then the prints almost completely disappear. So it does take some angle manipulation of the lamp. You can also adjust your exposure, like I mentioned earlier. You can see some more contrast. So again, a reflective surface would be difficult to photograph with a standard camera, but you put it under the RUVIS system, much easier. Okay, this is a Forensic magazine, and there's a couple prints up down here at the bottom that were lightly fumed for a couple minutes. A glossy surface, reflective, almost blotch white. So when you're looking at the prints, just with your naked eye, you can't really see anything. Except you can see that there are prints there, but to take an image of it would be cumbersome. I'll crank my exposure time up just a little bit. And obviously it's way out of focus, so I'm going to manipulate that. So depending on the size of the piece of evidence you're working with, you'll need to manipulate the focus and bring the RUVIS camera up or down the mount here. See him coming in focus right there. And again, I do want to emphasize this. The resolution from the Mac up to the projector and out doesn't really do it justice. Even in the viewing, as I'm viewing it here, because of the imaging card, as it takes the data up there, kind of halves it on my end too. So afterward, if you want to see it at full 27-inch display, I'd invite you to come down. But again, shortwave takes the background out completely, and you can see your prints. Any questions? Yeah.
Is this black and white, or do you have other?
The image itself? Yeah, it's black and white. Yep. Good question. Okay,
Go ahead. Another question.
yeah,
Is that the only way to focus manually?
yes, yeah, just focus manually right here. Yeah, there's no autofocus. And the reason that is if there was an autofocus, as you're changing different pieces of evidence, the size of the evidence really matters as far as how it focuses. So if you have a little, maybe a bullet or a pen or something like that, and you autofocus it, then it's not going to focus right on that print. You really want to make sure that you have control of that focus. And so the image is lined up directly above the print, and you can focus right in on that print. Good question.
Okay, I got a question, Parker.
Yeah.
So with, I noticed a lot of stuff you were doing was dealing mainly with like things that are fumed, like as far as prints go. How does that work with like checks or money and using like dye stains on that kind of stuff and taking out background? Have you tried it with like anhydrous or like your PD paper and looking at it under the RUVIS with to see prints and extract the background from like multicolored pattern papers and
Yeah,
stuff?
that's a good question. Typically, the best results I've seen with anything processed with dye stains, like rhodamine or anhydrous, DFO, indane-dione, whatever your department uses, is going to be mostly in the 450 range.
But you can
if
still-
you use the UV and try the shortwave UV, because you want the background to be manipulated or dropped out, you're not going to get the fluorescing that you would using a 450 light. That's what, in my experience, that's what I've seen. That's a good question, though. Quinn, do you have anything to add to that?
Shortwave is typically what removes the background.
Okay.
So when you get into, like earlier we did the PDMAC paper where you could still see underneath it how much we spent at Toys R Us.
Yeah.
So it's still there, so it won't eliminate the background on those applications. So.
Okay, okay.
Good question. Okay, so that's about 5 or 6 pieces of evidence for shortwave. I'm going to move into the visible range now and show you some processed fingerprints with anhydrous. So all I'm doing now is switching the filter out from convex 254 to an orange filter. Now, obviously at this point with just the room lighting, you're not going to be able to see anything. Once I focus it and hit it with an alternate light source, this is my Toys R Us one, Amanda, thank you. I have a 3.5-year-old son, so I'm up there quite a bit. So again, the angle of the light is very important. As you can tell, when I take the light and shine the full power of this alternate light source on, it completely blows it out. But if I manipulate the angle of the light, it makes a huge difference. So some people have asked, and I do understand this question, can't we make it hands-free? You know, can't I mount my light on something? And the answer is yes, we do have a clamp system that you can easily clamp onto the copy stand and then clamp your light on. However, it would be difficult to manipulate the angle of the lighting that way. And so it's very important when using a RUVIS system that you're able to manipulate the angle. So an anhydrous-based blue light, orange filter. Again, full spectrum imaging system, not just UV. You capture your image and you're done. There's more prints up there you can see that I didn't initially see. Let's see what those look like. very visible. Let's do a couple more here. Here's one more receipt that was processed. So all I'm doing at this point is just manipulating the focus lens right here and bringing it in and out of focus, just make it a little clearer. I might even turn the aperture down, take that noise out a little bit. So my f-stop went from 3.6 up to 5, I think it's 3 up to 5.6. So closing out the light just a little bit gives a little more contrast with the print and the light source coming in. No real need to manipulate the exposure on this one, or the gamma or the gain. You just take the picture and it'll be 1,000 pixels per inch. Actually, it'll be about 2,000 pixels per inch. Let me show you one in infrared. Any questions? You guys doing okay? Good.
Yep.
There's also some semen, urine, and saliva that I did not get into, but if you want to see it, come on down later afterwards.
Right here.
So this is an impression that was lifted with our stat lift. This is a vinyl material. It's a brand new product. About a year ago we launched this, and simply lift the dust off of the surface and it will reveal your foot impression. So I switched the lens to infrared, and then this system does come equipped with an infrared light. Okay, the reason I moved it up so high, this is about 18 inches off of the surface, is because the impression is obviously going to be a lot bigger than a latent print. So obviously it's out of focus at this point. I'm going to manipulate the focus. Here's part of the foot impression. Foot impression requirement, as we mentioned earlier, is not 1,000 pixels per inch. There is no requirement. The only thing they ask you when you submit to their database is that you fill the image with at least part of the shoe impression. So for you impression people out there, this would meet that requirement pretty easily. So this is taken directly off of the stat lift, which was used to lift the impression off of, I believe it was tile. I've got more exemplars, but I know we're kind of running out of time. Any questions? I know we went through a lot real quickly. Typically, our workshops, we host them at our facility. We travel all around the country. It can go from an hour to 4 to 5 hours, because you can really get into a lot of detail and a lot of different types of evidence. Question documents, as you saw in the exemplar on the slideshow, anywhere from UV all the way up to infrared.
Does this also include the protective gear for like eyewear and the...
Great question. Yes, it does. Goggles, safety goggles. So I should have mentioned this earlier, but if you're working in the shortwave UV, that's the reason I wore my glasses today, that you always want to wear protective eyewear. If you're exposed to it for longer than 30 minutes or so, it could damage your eyes. So make sure you're wearing goggles. These are just UV protective goggles. If you're wearing these, you're just fine. Or a face shield, we have those. That comes equipped with the system as well. And orange goggles come with it, that allow you to view your biologicals before you capture. Good question. It also comes with nylon gloves. Yeah, I should have been wearing those, but I do this so much that I kind of forget. Great question. Anybody else? All right, very good. Thank you guys, we appreciate it. If you have any questions afterward, please come down. We've got our laser set up and the mobile version. This is obviously set up, but I think someone else is going to present here shortly anytime, okay? So we'll take this down, but any questions coming up and ask, and
We better ask questions for them.
yes, real quickly, real quickly.
Sweatshirt on the line.
Hoodie. Okay, what is the APHIS pixels per inch requirement for late submission? 1,000. Very good. Give her a hand. Very good. Keep paying attention. All right. Number 2. Name one light wavelength you can use to capture an image with our RUVIS system. Wavelength. Yes, very good. Take it.
That's confidence right there.
Very good.
Gee, I wish still saw it.
Last one. Okay, what is the largest size image in inches you can capture while still fulfilling the 1,000 PPI comparison requirement?
4x4.
Very good. Yes. Awesome. Give her a hand. Guys, thank you so much. We appreciate your attention.